Good day viewers. In today's lecture we'll be looking at tangent and normal to the parabola. If you are new to this channel, make sure you subscribe, turn on the notification bell so that you'll be notified when new video drops. Now, tangent and normal to a parabola, yes. So what does this mean and why are we discussing it? If I have a parabola, this is the parabola we have been discussing. So this is just a random sketch. So if the parabola is at the origin, we know what that means. A parabola of this nature, y squared equals to 4as. Okay, so we know we have our directories at this side. Our focus is here, but this doesn't really matter now because that is not our focus. So this is a point on the parabola like this. There's a straight line that runs across the parabola. Okay, so that line touches the parabola at a point. We can call that point Q to be this, to have this coordinate. So this line is what we call the tangent. Okay, so there is a line that is 90 degrees to the tangent. This line is what we call the normal. Okay, they both share the same point. They both share the same point, just that the normal is perpendicular to the tangent. So what we are going to be doing in this course will be looking for the equation, because this is a line now, so we'll be looking for the equation of the tangent using the parabola, and also be looking for the equation of the normal using the parabola also. So let's get started. So we are looking for the equation of the tangent. So at the points, let's say s1 comma y1. Okay, so remember, when you are looking for the equation of a line, we always look for the slope. We need the slope. So we are dealing with the parabola, so we need the slope of this parabola now. That's what we need. That will be the slope of the tangent. So let's get the slope. To get the slope, you differentiate this. If you differentiate this, you get 2y. So because we are differentiating with respect to x, and this is y, it is y we've differentiate, you must add dy ds to it. Let me come again. We are differentiating with respect to x, but because we differentiated y, you must add dy ds when you are done differentiating y. So we call that implicit derivative. If you differentiate this, you get 4a. You don't need to add ds. Even if you add ds, you get 1. So we are differentiating with respect to s. You don't need to add the dy ds. It's only when you differentiate another function that depend on another function. So that's when you add your dy ds. So what we are looking for is dy ds. So if you make dy ds out of formula, you get 4a over 2y. And I think there is something common, which is 2. 2 here 1, 2 here 2, so you get 2a over y. Okay, so this is your dy ds. So the slope, of the slope of the tangent, okay, the slope of the tangent to the parabola now. So at s1 and y1 will now be m. So this, in place of the y ds, we say m. Then anywhere we see s, we put s1. Anywhere we see y, we put y1. So in this equation there is no s, we only have y. So that y becomes y1. So this becomes your slope. Okay. So now that we've gotten our slope, what will now be our equation? What will be our equation? So we use this equation of a line formula equals to what? M. So your s1 is already s1 here, your y1 is already the y1 here. So let's continue. So what is m? 2a over y1. Okay, if we cross multiply, that will give you y1 into y minus y1 equals 2a into x minus x1. Okay, and then if you open this bracket, you get y1 minus y1 y1, so that is like y1 squared. They are the same, so you can square it. 2s1 minus 2as1. But we know something. We are dealing with a parabola, so this y1 squared will actually be equals to as1. Equation of parabola is y squared is equals to 4as. If I have y1, y11 will just be there like that. So we are going to replace this by that. So we get 4as1 equals to 2as minus 2as1. So with this, there are terms that are common. y1 equals 2as plus 4as1 minus 2as1. So this will give you 2as plus 2as1 equals y1 like this. Okay, so you can factorize a common term, you get s plus s1. So you can also use this formula to get what? Equation of a tangent. You see in an example now, so that is why you have to watch this video to the end. In an example now, you will see how I use this formula to get the equation of the tangent. Okay, but you can also just get your slope, which is what I did here, and then insert your slope here, put your y1, put your y2, cross multiply, you still get your, like, I mean, you can also use this equation, this equation, to get your equation of the tangent. But if you want to be very fast, you can use this other one, depending on the one you understand. So before we look at an example, let's talk about the one of this the equation of the normal. Okay, so let's talk about the equation of the normal. So before we do that, we need to know the slope. Let me just write normal here, so you know that we started discussing about the normal. So what will be the slope of the normal? So say let the slope of the normal be m2, right? So you know the normal is perpendicular to the tangent. We said this before in our diagram. If you look at the diagram I gave, I told you the normal is perpendicular to the tangent, and because of that, m1 times m2 will be equals to -1. Okay, we are looking for m2. So what is m1? We can call this the one of the tangent to be m1. Okay, so our m1 is 2a over y1. So we can just say m1 is 2a over y1. So it's the slope of that tangent that you got. You just name it m1. Okay, so that would be 2a over y1 is equals to -1. That would be 2a m2 over m1 y1 equals to this. Okay, so we are looking for m2. So if you cross multiply, you have m2 is 2a is equals to -y1. If you divide by 2a, you get divided by 2. So this becomes the equation of the normal. This becomes the slope of the normal, sorry. So the equation will be y minus y1 over s minus s1. So instead of using the one you used before, which is m1, this time around you use m2, y1 over 2a. So this is how you get your normal. Okay, let's consider this example. Say find the equation of the normal to the parabola y squared equals 8s. So at the point -4 and 1. Solution. So we have y squared is equals to as. So remember, what we are looking for now is equation of the normal. So to use the equation of the normal, we need the slope. So to get the slope, you need to do dy dx. So differentiating this, you get 2y dy dx. Differentiating this, you get 8. So dy dx now becomes 8 over 2y. That will give you 4 over y. Okay, so what will now be the slope? So this is slope of the tangent. This is the slope of the tangent. This is slope of tangent at -4, 1. So we get m, you can say m1 is equals to 4 over 1, because at this point, this is your s1, this is your y1. So the one I wrote as y1 that time is now 1 in this case. So we have 4 to be our m1. So what we are looking for in this question is the equation of the normal. So we need the slope for the normal. So you know the normal is perpendicular to the, you can just say let the slope of the normal be what? M2. So M2 times M1 is equals to -1. Why? They are perpendicular. So the slope of the tangent is perpendicular to the slope of the normal. So what is the tangent? It is 4. Okay. So to get M2, you divide both sides by 4. So you get -1 over 4. So the equation now, equation of the normal. So you now use the equation formula. So which is y minus y1 over s minus s1 equals m, say m2 equals m. This is the equation of a normal, this is equation of a line. So let's use it to get our normal. So what is y1? We're given -4, 1, right, to be the point. So that will be 1 at that point. So this is s minus. So what is s1? S1 is -4. So what is m1? -1 over 4. So you get y minus 1 over s plus 4 equals -1 over 4. Okay, so let's cross multiply. So you get 4 into y minus 1 equals -1 into x plus 4. So that will give you 4y minus 4 equals -s minus 4. 4y equals -x minus 4 plus 4. Minus 4 plus 4. So you get 4y is equals to -x. Y is equals to -s over 4. So this is the equation. Okay, so this is the equation of the normal. So that is the answer. Okay, so let's look at another example. So let's say example 2. So you say find the equation of the tangent. So to the parabola for years at the point so we are given this equation, y squared is equals to 4as. Okay, so let's get the equation of the tangent. So there is a formula that says if I have, or if you come back to this equation, that we did, you could see the equation of the tangent. If you have y squared is equals to 4as, yes, y squared is equals to 4as, your equation of the tangent is y1 equals to 2as plus s1. Okay, so if I have y squared is equals to 4as, my equation of tangent is y1 equals to 2as plus s1. This is very fast. So what is y1? y1 is, we are dealing with this point. So this is s1, this is y1. So y1 is t, ys1 is s. So if I make y set of formula, I get 2a over t into s plus s. You can open bracket if you wish. So you have this over s over t plus 2as over t. So this is the equation of the tangent. So you don't have to differentiate. Although if you differentiate, find the slope, do everything, you still fall back to the same answer. Okay. I want us to do something again. Let's do another example at the point that solution. So yes, we have this equation y squared equals to 14s. So I want to show us how we can use this template. If we have this equation, the equation of parabola is y1 equals 2a then s plus s1. So how can you use this formula? So first of all, you see that if I have my y squared, I will change it to y1 equals to, you see this was 4. In this equation, you have to divide the 4 by 2, you get 2. Your a remains the same, so it doesn't really concern the a. You just have to divide the 4a by 2, then you get this side. Then this other side is just s plus s1, so you just have to write s plus s1. So after you divide this by 2, you write this s plus s1. Okay, so for this equation now, we'll change the y squared to y1. Okay, we divide this one by 2, that is minus 14 divided by 2. Then we change this s to s plus s1. So that is all you need to do. As simple as that. So if you write this, you get y1 equals minus 7 s plus s1. So what is, we are dealing with this point. So this is s1, this is y1. So just put it there. You get minus 3, and then what is s1? You get 1. Okay, so that will give you minus 3y equals minus 7, maybe x plus 1. So if you divide by minus 3, you get 7 over minus 3 into s plus 1. So this will give you 7 over 3, then s plus 1. If you decide to open the bracket, you get 7x over 3 plus 7 over 3. See, you don't have to look for normal, you don't have to look for the slope. With this formula, you just be flying in multiple colors. Now, let's look at one more example. So, and these examples, they are very, very important. You make sure you watch them to the end. Stay to the end so that you won't miss any parts. Now, the last example now, which is example 3, and I don't know, maybe it's example 4 now. Now, we have this important question. It says solution. Now let's read. It says find the point of intersection of this line and this point, and the equations of the tangents and the normals to the parabola at that point of intersection. You see, when I gave my explanation in the beginning, I told us that there is a parabola. Let's assume this is a parabola. I told us there is a line that runs across that parabola, and that line meets the parabola at a point. Okay, so it is at that point we are now looking for the equation of the tangent at that point and also the normal at that point. So this question is just like saying the same thing. Find the point of intersection of a line. So this line now that I just drew here, it is now named to be this. And the parabola, this parabola now is called y squared is equals to 6x. Okay, and the question of they say we should find the point. So we are looking for Q now. We are looking for that point of intersection. So with that point of intersection, once we get our Q, we can now solve for tangent and normal, which is very easy. Now let's do something. Now, to get the point of intersection, whenever they ask you for point of intersection, we use this simultaneous equation. Okay, and this is how it works. X minus 2y plus 6 equals 0, right? So you make a set of formula, you get 2y minus 6. Okay, and so we put this, if this other one is the second equation. Okay, so if you call this equation 2 now, so this is equation 1. So put this into 2. What are we going to get? We get y squared equals, in place of x we write 2y minus 6. This will give you 12y 36. So now you get y squared minus 12y plus 36 equals 0. Okay, so at this point, let's solve. Two number you will times that will give you 36. If you add them to give you minus 12, that is 6. Okay, that is 6, and it is minus 6 times minus 6 that will give you plus 36. If you add minus 6 and minus 6, you get minus 12. So this is what you get. So we just have y is equals to 6. Okay, so we have s. Remember that s is equals to 2y minus 6. So if you put what y is, what do you get? You get 12 minus 6, which is 6. So what happened? We have the same point. So x comma y now is equal to 6 comma 6. So what that means in that diagram is that this q is now 6 comma 6. So now let's get our tangent and our normal. So the equation we are given is y squared is equals to 6x, right? And then the point we now have is 6 comma 6. So to get the equation of tangent, so remember what I explained. You change this y squared to y1, and this 6 you divide it by 2, and then the s you write s plus s1. Okay, so that is the formula. So what is y1? It is 6. 2 divided by that is 3, and s1 is also 6. Okay, if I divide through by 6, I will get this. So this will give me 1 over 2 s plus 6. So that will give you x over 2 plus 6 over 2, which is still x over 2 plus 3. Now this is your equation of tangent. So this is the equation of the tangent. Okay, so we need equation of the normal. So for normal, we need equation for normal. So for the normal, this is what you will do. I want to show us another thing that will help you to be very, very fast if you are doing this in an examination hall. So remember, if the slope, we just need the slope now. The slope of the normal, let's call it m2. Okay, and you know that the normal is perpendicular to the tangent. So what is the slope of the tangent? You know, we didn't do dy ds, so we didn't solve for the slope first, but now we've gotten an equation, and you know that from this equation we can actually get the slope of the tangent. This is the formula. So this coefficient of x is the slope. Okay, so the slope of the tangent. So from that equation now, you can still get the slope of the tangent, m1. It is the coefficient. In this case, it is 1 over 2. Okay, so the normal now will be m1 times m2 equals minus 1. So m2 times 1 over 2 equals this. So which is m2 over 2, sorry, equals minus 1. So what is m2? It is minus 2. Okay, so what will be your equation now? You know your formula. What is y1 and y2? 6 and 6. So just say y minus 6 over x minus 6 equals minus 2. So y minus 6 equals minus 2 into x minus 6. So that will give you minus 2x plus 12. So y equals minus 2x plus 12 plus 6. Y is equals to minus 2x plus 18. Minus 2x plus, so this is your equation. Okay, this is the equation of the normal. Equation of normal. So the one we had before was equation of the, this is equation of the tangent, and the last one now is equation of the normal. So thank you very much. Thank you for staying to the end. See you in the next video.